This video will be a few practice problems on concavity and the second derivative. This is relevant for both AP Calculus, AB, and BC. Okay, so problem number one, let's get started right away. This is a follow along, so I would recommend you try the problem first. Once it appears on screen, pause the video to try it, and then unpause it to see the solution. Let me get rid of this. And see the solution, and let me adjust this as well, sorry. See the solution, and if you got totally stuck, you can try to understand how I think through the problem as I'm thinking out loud, okay? Or sharing my thought process. All right, number one, describe the concavity of the generic linear function y equals ax plus b and interpret your answer. Okay, so hopefully you tried it. This guy has no concavity. There's a few ways to think about it, okay? Concavity is related to the second derivative. So what's the second derivative of y? First derivative is just a. The second derivative is 0. Okay, so because the second derivative is 0, it's neither positive nor negative. It's this if the second derivative is positive or greater than 0, it's concave up. If it's negative or less than 0, it's concave down. It's neither. It's exactly 0. So it has no concavity. You can think of it like that. Secondly, you can just think of it as, I didn't write it here. Is it opening upward or is it opening downward? Like the shape of a bowl. Is the bowl right side up, which is concave up, or upside down, which is concave down? It's neither in this case. Okay, that's a quick way to kind of think about most of these problems. Just which way is it opening up or is it opening down? You might get tricked though, so that might be a different problem, foreshadowing or sneak peek of a future problem. But the other way to think about it is concavity is related to the rate of change. The first derivative is the rate of change. The second derivative is the rate of the rate of change. The rate of change of the rate of change. Okay, so is the rate of change changing? No, because the first derivative, which is the rate of change of y, is constant. It's just a. It's not changing. So that's another way to think about it for why the sky has no concavity. Okay, number two. On what intervals is g concave up on the interval 0 to 2 pi? Okay, so as I said earlier, we probably want to find the second derivative, and it's concave up when the second derivative is positive. Okay, so let's differentiate this twice. But before that, if you know a simple trig identity for students in AP Calc BC, you probably know this from the trig integral or the trig subsection. You can replace sine of 2x with 2 sine x cosine x, and then the sine x would cancel so that it's 2 cosine squared x. G of x is 2 cosine squared x. This is much easier to differentiate than this over here. We need quotient rule, product rule, chain rule, all that business over there. For this, you just need the chain rule, power rule, chain rule. Okay, so we first find g prime. So here it will be 4 cosine x times negative sine x. So then we can use that identity to write it back as minus sine of 2x. Okay, now we differentiate from here. So that we wrote it like this because I don't have to use the product rule. I just use the chain rule here. So it's minus 2 cosine 2x. Okay, we set it equal to 0 to find the critical points. So that in the interval 0 to 2 pi, because cosine 2x has an infinite number of solutions, and this interval is just pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, so we do the sign test. So draw a number line with the critical points, plug in numbers within each interval, get the sign of y double prime. You should get this, okay? For example, I'll just do one. In this interval, pi over 4 to 3 pi over 4, you can plug in pi over 2. So what is cosine of 2 times pi over 2? Well, 2 times pi over 2 is pi. So what's cosine of pi? That's -1. -1 times -2, that is positive. So that's why it's like that there, okay? So you have to plug in a point in each one. And you see that this is positive. This region's positive. So that's where it's concave up between these two intervals. Okay, 3a, we're going to describe the concavity of f. We're given f double prime here. Okay, so this one's simpler one in this multi-part problem. F is concave up when the second derivative is positive. F is concave down when the second derivative is negative. So the second derivative, F double prime, is negative from, what's this? -3 to -1, not inclusive. Okay, don't use the square brackets, use the parentheses. And it's concave up from -1 to, what is this? That looks like 5. 1, 2, 3, 4, 5. Yeah. That's over here. So I didn't use interval notation, but don't put equal sign. Because remember, the second derivative, if the second derivative is 0, it's neither concave up nor concave down. It's a point of inflection if it switches from negative to positive or positive to negative. Remember that? Point of inflection switches concavity. Okay. At what values of x will f prime have its absolute max and absolute min values? Okay, so this is asking about f prime. So when does f prime have max min? When its derivative changes sign. So its derivative, the derivative of f prime is f double prime. So when does f double prime change sign? Right over here only. So there's a absolute, is it a max or a min? Well, the second derivative changes from negative to positive. That means f prime will have a min there. Why is that? Well, if it's negative, that means f prime's decreasing. If it's positive, that means f prime's increasing. Decreasing to increasing, that is a min. So there's a min at x is -1 for f prime. Okay? Oh, that's a relative min. Sorry, I didn't answer the question. I got ahead of myself. It's asking for absolute max min, not relative max min. So there is a relative min there, but is it the absolute min? So I'm trying not to look at what I wrote already. It is because we think about exactly, since f double prime is negative, f prime is decreasing. So it started from some value, it's decreasing, 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 decreasing up to here, and then it starts increasing onward. So this would be the absolute min actually at x is -1, okay? So that's what I'm probably saying over here, okay? And then where's the absolute max? Well, it started at some point, okay? It decreased, and then it keeps on increasing afterward. Look how much it's increasing. It kind of cancels out how much it decreased over here. And this is where the concept of integral would help, because this area is negative. This area is positive. For sure, this area is bigger than this area. So the absolute max would be at the end over here. X is equal to 5. Okay. If you don't know about integrals yet, just think of it as it's decreasing, 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 right? And the rate of decrease, the maximum rate of decrease is -2. Okay. Look how fast it's increasing actually. It's 1, 2, 3, 3, and even to 4 up here. So you can see it's increasing so much faster than it decreased. So that's why the absolute max would be at the end over here. Okay, that's the way to think about it in terms of derivatives, but if you know about integrals, it's even easier. All right, C, will f triple prime of 0 be positive or negative? What about the fourth derivative of f at 0? Okay, so how is f triple prime related to f double prime? It's derivative first, f double prime's first derivative, okay? So if f double prime is increasing, that means its derivative, it's positive. So at 0, is it increasing this function? It is. So that means f triple prime will be positive. Now, the fourth derivative is related to the second derivative's concavity. Okay? So is it concave up or is it concave down at this point, x is equal to 0? The quick way to think about it, it's opening downward, so it's concave down, meaning the fourth derivative, which is this guy's second derivative, is negative. Okay. Part D. On what intervals will f prime be concave down? Okay, so you got to be careful. It's asking about f prime's concavity, which means we need this f prime's second derivative, which is this guy's derivative. So you got to be flexible in thinking about all these things. Okay, they ask so many different types of questions in just one simple graph. Okay, so f prime will be concave down when f triple prime is negative. F triple prime is negative when f double prime is decreasing. This is how we think of it. See, you got to be flexible to think about it in all these different ways. And basically you just got to have those concepts down. When it's increasing, decreasing, and concavity, when it's concave up, concave down, when is the first or second derivative positive, negative. You have to get those down. No way around it. Okay, so as I was saying, f prime will be concave down when f triple prime is negative, and f triple prime is negative when f double prime is decreasing. So where is f double prime decreasing? So it's decreasing from -3 to -2, okay? And then it increases, and then it decreases from somewhere here. Let's just pick, it looks like it's around 2.5. I believe this graph is not to scale, so let's just say 2. And it decreases from 2 to 5. So f prime is concave down from -3 to -2 and 2 to 5. That's what I said to there. Okay? All right. One more. Not as bad as the others, in my opinion. Okay. H prime is given below. Describe the concavity of h of x given h of x is continuous. Okay, so remember earlier in the video, if you stayed till now, I was saying, I was foreshadowing something a little bit. This is the problem, okay? There's two ways to think about this. The better way is method 1, which I'll talk about right now. Method 2, you got to be more careful. All right, so concavity is related to second derivative. So this is the first derivative. What happens when we differentiate this? Well, this point is not differentiable because it's not continuous, okay? So we ignore that first. But the derivative of this h prime when x is less than 2 is 0. And when x is greater than 2 is also 0. So is there concavity? No, because it's always 0. And at this point, the derivative does not even exist. So there's no concavity, actually. That's what I'm saying here. Okay, method 2, this is where you got to be careful. You could think of what function could this h be? And it's actually quite easy to determine because, well, we understand that h prime is slope of the tangent line or rate of change. So it's a constant rate of change. And over here as well. That means h must be a linear line for x is less than 2 with a slope of 4. And after x is equal to 2, it's a linear line, a slope of -4. Which function does that sound like? Absolute value. Okay? It's not differentiable right here at the sharp turn, but it's continuous. The problem said it's continuous, right? So it is continuous. It's just not differentiable because of the sharp turn. Okay? So if you determine that this is a function, you might be tempted to think this is concave down. If you think of it's opening downward, but this is where you would get tricked. That way of thinking, that kind of analogy, that bowl opening up or down, doesn't work in this case. If most analogies have some weakness or have some flaw. You can't cover everything. So this is one of them. Okay? Because we understand that concavity has to relate to the rate of change. Rate of change of the rate of change, which is what I was explaining in method 1. The rate of change of the rate of change is 0 everywhere except at this corner. Okay? So if you think of it like this, don't say that it's concave down because it's technically not right. Okay? All right, that's it for this problem set. Hopefully this was helpful. And the important one, to be honest, was number 3. So if you struggled with that, I would recommend you review it, watch it again, redo the problems, do some more similar ones because these types of things appear on the AP exam very, very often. Okay, especially on the multiple choice. They will just give you f prime. They'll ask you about f and f double prime, maybe even f triple prime, or this one, they give you f double prime. They ask you about f prime, f triple prime, and even the fourth derivative. It can give you f and ask you about f prime, f double prime, f triple prime even. They can ask you a lot of stuff, okay? So that's why you got to be flexible in thinking about all these things. All right. Hopefully this was helpful. Please give this video a like if it helped you in any way, and hopefully I'll see you in another video as well. Bye.